Hi everyone, I'm Damilare Babatunde, a PhD candidate at the Department of Chemistry, University of South Africa, under the supervision of Professor Mketo and Professor Magwa. Let me tell you about my research on a comprehensive DFT study of magnetic cellulose nanocomposite for azote removal of Venlafaxine and its transformational products from wastewater. Depression is a widespread chronic mental illness affecting approximately 10.7% of the world population, with significant effects on emotions, cognition, and psychological dysfunction. Antidepressant prescription rose by 88.3% after COVID 19, reflecting both rising depression rates and the emergence of new ATDs. Venlafaxine, a widely used ATD, and its active transformational products persist in wastewater due to incomplete metabolism. Conventional activated sludge systems show poor removal of psychotropic drugs, with Venlafaxine removal approximately 40%. This calls for a need for sustainable adsorbent. Therefore, cellulose nanocrystals derived from renewable biomass offer high surface area, tunable chemistry, and diverse functional groups for adsorption. Magnetite functionalized cellulose nanocrystal had magnetic separability and ion 3 active sites. Using Gaussian system on the CHPC Lengal cluster for DFT calculations, we were able to optimize the molecules and complexes both in gas and solvent medium using variable basis sets with about 24 cores shared memory and 15 gigabyte percentage memory. With the DFT, we're able to provide insight into adsorption energetics and mechanisms, charge transfer, orbital distributions, and molecular interactions between the adsorbent and the adsorbate for sustainable water treatment. These complement experiment and guide adsorbent design. Thank you.